I've had it, but I just haven't worn it much. So.
Why is there a balloon over there?
Is it okay?
Yeah.
What's that?
Why is there a balloon over there?
I don't know. Buzz was trying to go infinity and beyond, I guess.
You sure?
Not enough helium in it.
My
Makes sense.
God.
You know, Tuesday night we took the basketball girls to a movie, and there was a trailer out the other night, and there's going to be a movie just about him. So,
Buzz Lightyear?
yep. Showing up. I was like, sweet. I know I'll make sure I get there for that.
Can we make
so.
a field trip? Or can
We should, shouldn't we?
We should.
Hey, to infinity.
This is right.
Like infinity, right? Don't we talk about that here?
We do.
Yeah, we can relate this to that.
I think that that's an easy one to say. We've made a connection, so we should be allowed to go watch the movie, right?
I think so.
You know what? They have $5 Tuesday mornings. Maybe I'll just see if I can't
And
pull it
I
off.
think
Maybe we
students
should just say we're gonna study the statistics of the movie.
Yeah.
All of
Even
it.
though we're in calculus.
Yeah.
If it gives us an excuse to go, let's go.
Exactly.
I'm in stats, so
They
I
don't
guess
know
it
the
would
I'll
apply.
say this, what do you have first hour? We'll miss first hour, we'll plan to meet at Village Inn first, we'll all meet at Village Inn, and
Oh, I
then
love
just
Village Inn.
deal.
You actually
Perfect.
like count the calories.
And you know what? I don't ever take field trips.
Yeah, why?
So I'm not really an expense to the district, maybe for
If-
once.
If Mr. Loftus can take one every other day.
Yeah.
Hey, yeah,
I can take one. What? I'm not talking
I
crap.
think-
I'm just literally
I think
stating
the
facts.
only, I think the only field trip I ever took was, remember when they had the air show up in,
Yeah, we were
were
talking
you
about that in
freshman
EPS.
yet, or were you still in,
In Cedar Falls?
yeah?
We were talking about that in EPS.
Did you guys get to go to that or not?
No.
No, that was years ago. I got a bunch of kids in all my math classes to go to that, so we got to go,
The thing on the ceiling on that picture?
we got to go a day early, and so a lot of kids got to sit in all of the, like, the helicopters and the planes and stuff like that, so it was pretty cool, and there was a lot of people there. It was neat for them to be up and close to that, so I thought that was pretty fun. So that's about the only field trip I've ever done, so maybe it's
Well, I
time,
think it's time to do
maybe
it.
it's time to resurrect the field trip, huh?
Yeah, let's do it.
Let's think about it.
Road trip to Vegas.
I went to Vegas once, I came back married,
Sure did.
but it was planned.
Uh,
Okay. Alright.
Wait, you seriously
So-
got married in Vegas?
I did.
You didn't know that? No.
Seriously, yeah. We, my wife and I, we just wanted a big wedding, so neither do I, so we researched Las Vegas, and everybody says he's thinking of getting married by Elvis, which is not true, because he's dead. Alright,
No, he's not.
yes,
Yes,
I
he
am.
is.
Okay, alright, okay. He died on a hopper, okay? But yeah, we searched the place. There's actually, do you know, it's like the Las Vegas Strip is like the most important thing out there, but did you know the first building ever put up there was called the Little Church of the West?
Yeah.
And the Little Church of the West is
That's
considered.
insane. Like
What's that?
actually, that's
True.
actually.
Yep, it's true. Little Church of the West is considered a National Historic Landmark, so it'll never be torn down, okay? And so we got married there, but we were, I don't know, we flew out, we got up the next morning, we got all dressed up even, we like did the whole thing, and we were like dressed early on Saturday morning. I was like, I'm hungry, and my wife's like, yeah, I'm hungry too.
The
But my
buffets?
wife to be
Nope, they went.
listen, oh, it gets better. We were like, I'm hungry. I was like, so we were walking down the Las Vegas Strip, me and my tux in our wedding dress, not sure what we were really doing, and it's like, well, there's a McDonald's over there, let's go. Okay, and so we walked in, and that place was packed. It was like the lunch line downstairs. Okay, they saw
On
us walk.
breakfast day?
Yeah, people walked in. No, at lunchtime, like at lunchtime.
Oh.
People walked. We walked in, dressed up. People looked, turned around, and they just did this.
Part of the Red Sea
I'm serious. They said, you guys ordered first. So, okay, so we eat and we walk back, all right? We walk back, we go get married, and as we're getting married, and the guy is talking, and yep, and he's like, I even had this one lady, they said that they saw this lovely couple at the McDonald's, okay?
The McDonald's.
Yeah, this guy that married us was obviously at McDonald's before he came to marry us, so somebody was like, yeah, it was the craziest thing, so.
That's crazy. I've never heard that.
Yeah,
We heard it, I think, what, first?
Yeah,
Maybe it was last year.
Like, I didn't know it, but
So,
I remember.
you know, it was kind of funny, the single guy here at school, cause like who's the single guy in school now, who's the single teacher in
Mr.
school?
Cloud.
Yeah, Mr. Cloud.
Yeah,
No,
so
he
he'd
has
be-
a girlfriend.
So,
He just
No, Mr. Bosch.
yeah,
Oh.
it was funny, didn't say a word to anybody, none of the teachers knew.
Maybe we should cut this out of the video.
Yeah, maybe I should.
are we fooling? No one's gonna watch anyway.
Oh, that's true. It's only
Uh,
like 10 minutes.
But, yeah, it was funny because we had planned to fly out Friday and then come back home on Monday, and we said, we'll have the party and everything for people that wanna come for the celebration, so we just had like the party part of it when we got back.
But people knew that you were getting married in Vegas, or did you not tell anybody?
We didn't tell anybody, the only people that knew were my parents and her dad, and that was it, so.
Wow.
Yeah, so we got on a plane Friday, and I left school on a Friday, we drove to Cedar Rapids, we flew out, and I came back wearing a ring on Monday, and you should have seen the kids and the teachers, and it was like, what happened?
You didn't even take a day off work.
No. Well, here's the deal. We said, all right, we did it on a whim, it was like, we just both know, and we're like, I don't want an expensive wedding, and neither did she, and so I'm like, let's just go get this done, because I'm serious,
Let's
it's like,
go get it done.
it's like $300. Yeah, well, you know, my kids
That's the
ever,
way to do it.
my girls ever say they wanna get married that way, I'm gonna be like, here's the money, have a good time, we'll have a party when you get back, okay? Seriously, yeah, you know what, best decision I ever made, because you know what, I didn't have her stressing out about getting ready for a wedding, I didn't have to live with that for however long you plan it out, I'm serious, okay? I'm serious, men, hear me out on this, if you get a chance to elope, do it, okay? Do it, elope, that's what they call it, when you get married in Vegas, you're eloping it. Okay?
I've never heard of that.
Okay?
You've never heard of that.
Okay, so, you know, it was the best decision I ever made, okay? Best decision I ever made, okay? And then I found out she's a pretty good pie baker too, so. Perks. Alright, let's rock this here. I don't wanna spend a ton of time, this will be pretty easy to get done, but guys, remember yesterday we said the average value, you guys remember what the formula was for that?
Something over B minus A.
So it was the total integral, right? It was the total integral, and I'm gonna jot it down up here again, of A over B, f of x, or whatever function we're dealing with,
Over.
all over what?
B minus A.
Okay. So in this first one, I could use a calculator for this, but what I'd like to do is to use our fundamental theorem on this, so I'm gonna write this down, we're gonna use fundamental theorem on this. Because I think that these antiderivatives are pretty straightforward here. So in this situation right here, g of t is equal to what here, friends?
1 plus 2t.
And I want to find the average over the interval from what to what?
0 to 5.
So what this is going to look like, friends, this is going to look like the integral from 0 to 5 of our function 1 plus 2t dt all over what minus what?
Over 5 minus 0.
Okay, so from this right here, let's look at the top part right there, that 1 plus 2t. Do you guys know the antiderivative of 1? In other words, what would you take the derivative of to get to just 1?
T.
T. So the antiderivative here is going to be t. Okay, how about the antiderivative of 2t? If I added 1 up here, this would be 2t squared.
2t squared over
2, right? But what would the 2's do then if there was 2 over 2?
just be t squared.
Okay, so just check this real quickly, kids. If I took the derivative of t plus t squared, what's the derivative of t? 1. What's the derivative of t squared?
2t.
So do I have the right antiderivative here?
Yes.
We're going to evaluate this antiderivative at what limits?
0 and 5.
So I've got a 0 here, and a 5 here, and then you talk to me about the bottom. What's 5 minus 0 going to be?
5.
Okay. So my friends, let's do this fundamental theorem part now, down here at the bottom. Okay, let's plug in f of 5. So let's plug 5 in up here. So this would be 5 plus 5 squared, wouldn't it?
Yeah.
What's 5 plus 5 squared going to get you?
Third.
So this is going to be 30 minus f of 0. Plug 0 in. Plug 0 in there. What do you get?
0.
Okay? So it's going to be 30 minus 0 all over 5. So my friends, what's this going to be in the end?
It's going to be
6. So the average value of that function from 0 to 5 is what value?
6.
6. So if you had a line from 0 to 5 and you took all the values on that line, you took all the values on that line and averaged them out, all those values would average out to what value?
6.
6. Okay, let's try another one. Antiderivative of e to the t what would you take the derivative of to get e to the t?
E to the T.
So this will be the integral from 0 to 3 of e to the t dt. Call them home. Okay, so you said the antiderivative is e to the t, right? And we're gonna evaluate that at 0 and 3, and then divide by, what's the interval length here, kids?
Divided by 3.
Okay, now, I don't care how you do this. E is kind of a tricky one. If you want to leave answers in terms of E when we do this using fundamental theorem, that's cool, okay? But if you get to a situation, you know, and you want to know a decimal equivalency, plug it in. Guys, I write this as e to the third up top, right? That would be f of 3, wouldn't it?
Mm-hmm.
How about f of 0? We know e to the 0 would be what value? Anything to the 0 back. 1. So I can call this e to the third minus 1 all over what? 3. So that could work for us right there as an average value. Okay. I don't know if anybody typed that in. Did anybody go e to the third?
20.09.
20.09. Sounds about right. This is approximately. Okay. Guys, all I'm doing is finding antiderivatives, using fundamental theorem to evaluate the total integral within that interval. And then we take that total integral and divide it by, in this case, 3. We divide it by the interval length, okay? This next one's kind of unique, all right? I want to talk about this next one right here. The function is f of x equals what value, kids?
5.
Okay. Guys, if you took a test every time and you got whatever the score was, if you got 5 on everything, everything you ever did, you got a 5 on it, what would your average be? 5. This is saying it's like a function right here where f of x is equal to 5 right here. What's the average of all those points going to be then? It's going to be 5, right? Okay, I want to show you that this works for anything, okay? They don't even give you a value for lower limit and upper limit, do they?
Nope.
So here's the deal. This one here becomes the integral from a to b of 5 dx, right? All over b minus a, is that true? For an average value?
Yeah.
So you guys understand my top part for total integral?
Yeah.
Yes.
Do you understand my bottom part for interval length, upper limit minus lower limit?
Yep.
Okay, let's talk. What's the antiderivative of 5? This becomes 5x evaluated at what and what? So here's what we've got down here. And let's do f of b. If I plug b in for x, what's that become? 5b. So this is really 5b minus lower limit, f of the a,
Minus 5A
over what?
over B minus A.
But from this, couldn't I factor a 5 out of both terms up top? Which would really be 5 times b minus a over what?
B minus A.
Which leads us back to what we already knew, didn't it?
Yeah.
What the b minus a is going to do to each other?
Cancel.
It's going to cancel, right? You've got a value of 5. Okay. So again, average value, kids. Average value again. It's the integral of the lower limit a to upper limit b of f of x dx. All over what again?
B minus A.
So that's the formula we're kind of using. And sometimes, like, if you see it in the books, sometimes they'll pull this b minus a out front, they'll like write 1 over b minus a. Just know that means exactly the same thing, okay? All right, questions about those 3 examples right there? Anybody? Hey, all right, last example then. Kind of want to give you a good visual of this just to understand what's going on. Okay, so down here we've got a given graph right here. Okay, it says use the figure down here to find the total integral from what to what, kids?
1 to 6.
1 to 6. So let's see. 1 to 6 looks like it would be from lower limit 1 would be down here for x, right?
Mm-hmm.
Up to upper limit of 6. Okay. can we calculate the area of that pretty easily, counting boxes?
Yeah.
Let's do that. I've got 1, 2, 3, 4, 5, 6. I've got 7 full boxes that are 1 by 1, aren't they?
Yeah.
So I've got a total area of 7. Guys, what's going to be true of the areas that are cut in half here by triangles? So it'll just be 7.5 now total. 8. 8.5. Agree with that? Okay, so I'm going to clean that up here in a second, but the integral in part A for our, what is it, 1 to 6 of this function, f of x. What do we get for the total value when I add the area of displacement up down here? Okay, now the next question then is this, kids. Part B then says, what's the average value? So they want to know the average value. Well, the average value would equal your total integral of what? 8.5 over 6 minus 1, wouldn't it? Okay, so what's that total distance down below there in the denominator going to be? So we would go 8.5 divided by divided by 5, right? And I think that turns out to be about 1.7. Okay, so here's the deal, kids. If I could draw a bar up here, or a line up here, at about 1.7, 1.7 would be right about here, wouldn't it? Maybe? Okay. Guys, if I would go ahead and make a actually, I'm going to do something different. Let me do it this way. So if I made a rectangle up to about 1.7 here,
Equal the total area.
yep, that rectangle right there that has a y value up here of 1.7 all the way across tells me that all the values of these points and that blue line added together and divided by the interval length is going to be 1.7. The average of all the points on this blue line will be 1.7. And I know that because the area of this rectangle will be the same area as the displacement underneath the function f of x. Okay? Does that make sense to you? And think about these. Isn't this point and all of these points right up here at 2? Don't these points that are sloping down kind of bring that average of 2 down a little bit?
Yeah.
So does it make sense that our average is a little lower than 2 at 1.7? Okay. All right, friends. As far as the notes go, is there anything in there that I wrote yesterday when we had the copy machine problems? Is there anything in there that I wrote yesterday that you aren't 100% sure of what I wrote in?